All right, so the data set that we are trying to, or the problem that we are trying to solve here is basically these SVHN images, and these basically represent Street View images that are taken straight from Google Street View. And so we basically make a classifier. It's the problem is similar to the traditional MNIST data set problem, but it is way more complicated because images are blurry and it's way more difficult to read these images accurately. So basically, the way we tackle this problem is basically first I developed a more simple Keras API model, um, and as you will see soon, that did not give a high accuracy. So then I had to change a strategy and use a more sophisticated model, which turned out to be convolutional neural network, and we'll see how that one performs. But the reason we picked convolutional neural network was because it gives us more um, mathematical functionality that could help predict the scores better. So the dataset is available on this URL, and basically the dataset um, comes with 10 classes, where each class represents a digit, and is divided into training and testing set, and about 73,000 training set and 26,000 digits in the testing set. And basically, I picked the second format, which has cropped images of 32 by 32 pixel images, and the reason was it helps with data pre-processing. This saves us time, and we don't have to process too much. So basically, if we just wanted to visualize the data a bit, here I try to first how to transpose so that the images look neater, and then in the plot images code, which is the plot images method is more basically just trying to go through the image and print it out. And here we basically try to represent 16 different images. And another thing I wanted to see was how the testing set differentiates from is different from the training set. And it seems like the distribution of different classes or different digits is very similar. And in addition, we can also see how different classes or different digits come up in the data set. So first we go through the more simple model in Keras. And so the first task was obviously to load the data. And so we use the loadmat method from SciPy library, and then that load data method just returns the x and the y's, and basically it represents the images and the labels. And as we can see in the shape, we can see how the training and testing data set is different from each other, but have a similar shape to one another. So this is the basic layout of the model. It's pretty simple. It just has three layers. The first is a flatten layer. So we want to flatten the incoming data so we can feed it into the more densely connected neural layers. So flatten layer basically just takes a 3D tensor and then converts it into 1D array. And then we have two dense layers, and the first layer has 128 neurons, and the second layer is basically just is a softmax layer with just 10 nodes. And the reason we have 10 nodes is because we have 10 different classes or digits and we just wanted to calculate probabilities, or the outputs we want are basically probabilities for those 10 different digits. So this is the basic code that represents the model. And so not just the layers, but we also have to add some other metrics like loss function, which obviously will measure how much, will basically measure the model accuracy. And then optimizer basically helps us like improve the model as we train it more on the training data. And then so we train it over here. Accuracy seems to be constant, but even over here you can see the accuracy is not really promising. It's less than 10%, which is basically means that it's only predicting out of every 10 images, it's only predicting one image correctly, which is way lower than what we want. And finally, the test accuracy also comes out around 9%. Here, I just wanted to make a few predictions, just see. Somehow the first image gets predicted correctly, but I try to investigate it more and try to print up to 10 first images, and just a quick look just showed it only predicted just one image correctly out of 10. So the model does not work very well. So here I had to change my strategy, and instead I opted for a convolutional neural network, mostly for the different kind of layers and mathematical calculations that it allows us to do. For example, normalization, or calculating exponential decay, or adding max pooling layers. So I just want to see how adding this sophisticated model that could also be scalable can help us improve the accuracy. And over here, inference method, as in the provided source code, is an important method. That's where all the layers are created. And here you can see there are two 2D convolutional layers, and two max pool layers, and two normalization layers, and two fully connected layers. And finally, we have softmax linear transformation layer that produces the predictions for the 10 digits. So, and then TensorBoard gave us a very good diagram of the model on the right, which shows how the layers are stacked on each other. So going through the source code, there's four very important aspects or components of the whole network. And the first one is input, which basically loads the data files and pre-processes them, and returns the images and labels. And then the svhn.py is basically the entire model, and that's where the loss function is written and the inference method is written. And then next we have a training method, which contains the uses the methods in the model, and in the model defined in the previous class, and then runs them over a batch of runs. And then finally, once we have our model trained on the training data, we can call the svhn_eval.py, basically calls all the previous files and use the methods and classes defined in the previous classes, and tries to evaluate the model based on that. So some important methods that we use are inputs and distort inputs. Basically, they load and process the image. Inference and loss, as I mentioned, basically make important calculations and set up the layers. And finally, train, as it's pretty obvious, just trains the model and calculates loss and updates the variables. Um, so this is the first 100 steps in the training process. It's basically had 100,000. I tried to go to 100,000, but here for the first 100 steps, you can see the model basically decreases. The loss decreases, which is a good sign. So with that promising sign, after we run evaluation, it actually gives us 87 around 87% accuracy, which is very interesting because we were able to improve our accuracy from 10% to 87%, which shows how it was important to have our model set up correctly, and how like adding different strategy or a different approach to a machine learning model can help. So this graph, again given by TensorBoard, shows us how how the um, accuracy stacks up over the course of the evaluation process. And so that's basically how. So that's basically the end of the present the end of the discussion over the two models. Basically, it was a good learning experience to start a project from the start. So a few important things that I learned in this project was number one was importance of using a good data set and pre-processing the data. So basically, I had to um, pre-processing was a challenge because it, the data was in one particular shape, and my the way I had to like go through a trial and error of how best to process the data and then convert it into a data set in a TensorFlow. So that was like interesting problem, and then also setting up the layers and like how deciding how many layers to put on and how many neurons to put on every layer and which layer goes first and then the one after. So that was also challenging, and I think deciding which technology to use, like CNNs, as I was trying to go through different ideas, I had at one point thought about using LSTMs or RNNs, and there was also an interesting paper that I found on using um, CNNs with combining CNNs with RNNs. So it's a recurring convolutional neural network, which is a very novel idea and could be promising for the future. So so yeah, that was my experience from doing this final project. It was which was that it is a long and tedious process, and every step of the process is very important, especially like making the right decisions and picking the right data and then processing it properly, and then picking the right models and testing them for accuracy. And then overall, I think I was pretty happy with how the second CNN model performed, and then also by the experience of modeling for recognizing um, printed characters. So yeah, that's basically my case study, and I hope you liked it. Thank you.